Okay, so Carolyn had mentioned that I guess the previous talk that she was at, it actually wasn't climate change. It was about water, rooftop water systems for homes. And I am going to talk a little bit, just I have a slide about that in this presentation. Um, but I do want to share a little bit of the science because I think it's very important. The Baha'i faith says that science and religion must agree. Of course, God created the universe, and we understand it through science, and so um, it's very important also that when we talk about this issue with people, that we have some basis in the scientific facts about the issue. So let me, I have a thing that's on my screen that I have to move up a little bit. Okay, so the first thing is a little bit of history. The first person to mention, sorry, the first person to that is known to have mentioned the phenomenon called the greenhouse effect is Joseph Fourier. And some of you might actually remember him from your math courses. He was a mathematician, a physicist, and a historian. And in 1844, he described this phenomenon. And of course, it comes from the idea that when you have a greenhouse, the sun shine passes through the glass, and it basically it traps the heat inside. So that's easy to understand. In fact, you can all relate to this if you just think about your car. If you park your car out in the parking lot on a hot day and you get in and it's like 120 degrees, that is an sort of analogous to the greenhouse effect, because energy has come into the car, but it's now trapped, and so the temperature goes up. So, but in our world, the heating comes from solar radiation, and everything that is everything, every molecule, every atom in the universe that has a temperature above absolute zero emits radiation. So you emit radiation, the ground emits radiation, the um, the plants inside the greenhouse emit radiation. Now, the kind of radiation that we emit at these low temperatures relative to the sun is infrared radiation. And there's certain molecules that absorb that wavelength of radiation, infrared. And they happen to include water vapor, carbon dioxide, methane, nitrous oxide, and ozone. And so what happens is when the sun penetrates our atmosphere, it heats up the surface, and then the surface emits this infrared radiation, which under normal circumstances, most of it would pass out into space. But if you have these molecules like a blanket in the upper atmosphere, they will trap that heat and re-radiate it back to the earth. And what the net effect is that the atmosphere warms up. Another way to think about this is that you all know that in the desert, this during the daytime it gets really hot, but at nighttime it gets really cold. And the reason for that is at night, the warmth from the land is it emits this infrared radiation, but because of the clear sky, it goes to space. And so the atmosphere gets very, very cold at night. You may have also noticed that on a cloudy night, like during the winter, it's warmer than if you have a clear night. So water, in those examples, water vapor is the thing that is the greenhouse gas in the form of clouds. Okay, so what has happened in our Earth, in our atmosphere recently? At the start of the Industrial Revolution, we started to release a lot of carbon dioxide through our industrial processes in our modern civilization. And this graph shows the carbon dioxide concentration for the last 800,000 years. And you can see that it is averaging, it's oscillating a little bit, but not exceeding about 300 parts per million, which you can see over here. And then we get to about the 1840s, and it's straight up ever since then. And so this is like a very a big science experiment that we're performing right now, because for a very long time the concentrations have been much lower. In fact, an article came out just this last week that said that the Earth's carbon dioxide levels hit 4.5 million year high. And so this concentration of about 420 is parts per million is higher than it's been in the last 4 million years. So just what are these greenhouse gases? So we have CO2, methane, nitrous oxide, and then we have some fluorinated gases. And here it shows what the sources of, the primary sources of these gases are. But over here you can see the distribution of the emissions. So 82% of the emissions are carbon dioxide. And this was from 2016. 10% methane, 5% nitrous oxide, and then 3% from these fluorinated gases. Now, what's interesting is that if we use carbon dioxide as sort of the baseline, we'll call it has a relative strength of 1. Methane is 30 times stronger than carbon dioxide. Nitrous oxide is 280 times more potent, and the fluorinated gases are 23,000 times more potent than carbon dioxide. Now, we have these ones here, the concentrations in the atmosphere are quite low. In fact, the carbon dioxides are in parts per million. These are in parts per billion, and these are in parts per trillion. So luckily they are, otherwise we'd have a much more serious global warming situation. So I just wanted to show you a little animation of what is causing our atmosphere to warm up. And there are different natural causes that affect the temperature in the atmosphere. And so NASA developed a simulation model which separates the different factors: land use, ozone, aerosols, greenhouse gases, and I think there's a couple more, like volcanoes and the orbit of the Earth. And so I'm going to just go to this website, and I noticed when I was looking at it yesterday that apparently they updated it to go to 2014, but the model they're using only goes to 2005, but it gives a good idea of what's going on. So what you're looking at here is the CO2 concentration over the last, let's say, 120, 135 years roughly. And you can see, and if you went back into the past, it would be more or less the same, but then it starts to increase. And we're looking at a 1.4 degree increase, that's Fahrenheit, in 2005. So now I'm gonna go down, wait a minute. Okay, so this is the effect of orbital change. So the Earth wobbles on its axis and it tilts, and the orbital change over thousands of years can cause changes in our climate. So this, what we're looking at here, is from 1880 to 2004. So as you can see, that has had little to no effect on the temperature. This axis here is temperature, this vertical axis. And so it remained, its effect remained about zero. So what this is actually is that it's a climate model that has everything removed from it except the effect of orbital changes. Let's look at the solar effect. The sun's temperature varies over decades and centuries, and these changes have had little effect on the Earth's climate. So it's not the sun. Volcanoes. Volcanoes do not have a significant effect. In fact, volcanoes when they do erupt, they have the effect of cooling the atmosphere. So you can see here a couple eruptions occurred in 83 and 92. But here it says human industry emits about 1,000 times more CO2 than volcanic activity, and eruptions release sulfate chemicals that can cool the atmosphere. But we don't want, they also, the sulfate that's emitted from the industry though creates acid rain. So we really don't want that, even though it does create a little cooling. So let's add those three together and we can see the effect that they have. So if those three factors were active, this is the temperature we would be seeing. It would be close to the same as 1880. So now let's look at land use. And humans have cut, plowed, and paved more than half the Earth's land surface. And dark forests have yielded now have been converted to lighter areas because agricultural land is lighter than forest. So it actually created a little cooling. Why is that? When you have lighter surfaces, the sun is reflected. And so it creates a little bit of cooling. Now, this is not talking about the CO2 that came from the smoke. This is just talking about the effect of the land use change, okay? Let's look at ozone. So ozone is considered a greenhouse gas, but it really has a negligible effect. In the upper atmosphere, it blocks dangerous ultraviolet rays, and in the lower atmosphere, it's a pollutant. But it really doesn't affect the global warming much. Aerosols. These are things like sulfate aerosols from coal burning, and they actually create a cooling. So if you look at this effect all by itself, we would have a cooler atmosphere. But here it says, unfortunately, that it causes acid rain, so we wouldn't want that. So Now let's look at the greenhouse gases. And they create almost a 2-degree rise in temperature. But what we have to do now is we have to combine all of these things together because they're all happening at the same time and see how it compares with the observed. And so the model that takes into account all of these factors lines up very well with the uh, observed temperature rise. And as I mentioned, this is a model that was developed by NASA, and it's considered to be pretty accurate. So let's go back to the presentation. Um, let's see here. So here, I'm sorry to give you all this information, but what I want you to do is just glance at a few of these, and you can see what the effect of climate change and global warming has been. There's about 15 things here, and actually there's probably thousands of things that could be included in a list. But for example, reduction in agricultural yields due to elevated temperatures. Um, if you raise the temperature a few degrees, some plants, their yields will really be reduced. So we can expect that in parts of the world, there will be significant reductions in crop yields. Um, Agricultural workers in now and in the future may suffer from heat stress. One effect of elevated CO2 is that the nutritional levels of plants drops. So that means that people and animals would have to eat more in order to get the same nutrition. Um, uh, Crops use more water. This leads to competition between agricultural and non-agricultural water users. And there's other things that I won't take the time to go into. But well, some of these for you who are out in the West, more droughts, reservoirs dry out like Lake Mead. Water needs to be rationed. Farmers can't grow crops, etc. There is this concept of climate change acceleration and tipping points. So we have what's called the melting of the sea ice, where what happens is when the sea ice melts, the white ice is uh, changed to the dark blue ocean color, and so the ocean absorbs more heat, more radiant heat from the sun, and then it accelerates the melting. Um, there's the land ice has the same thing happen. When the land ice melts, it changes to the land surface. Land surfaces are darker than ice, and so it absorbs more heat, and then the melting becomes accelerated. The melting of the permafrost. There's large areas of the polar regions that are have permafrost down several meters into the ground, and in the past it basically remained permanent. It didn't melt, but now it's starting to melt, and it's releasing methane into the air, which I mentioned is a very potent greenhouse gas, and it can then accelerate the global warming process. In extinction of species, if you read news articles, you may have seen that every year we're losing so many hundreds or thousands of types of species, and we don't even understand how dependent we are on some of these species. Some that we do are, for example, honeybees, because they're pollinators. We greatly depend on those organisms, and so we're really playing with fire when we are causing the extinction of many types of species during this process of global warming. Competition for resources and social disorder. I think that you can imagine that people are kind of copacetic, kind of tranquilo until it comes to their neighborhood. And then we start to see social disruption. I read an article about there's some place in southern Oregon where a lake or a reservoir has been closed, and people want to, by force, they want to open up the floodgates and let the water out. And it's really a serious issue from a social standpoint. So there are numerous other worrying signs. I don't want to spend time on that because we already covered a number of those. But so what can we be done? Countless efforts have already been undertaken to address the problem, and these efforts will continue to grow in the future. What I'm talking about are the environmental organizations, the scientific community. For example, the scientific community has been developing the scientific apparatus for understanding climate change for the last 30 or 40 years, maybe probably longer than that. And so there has been a lot of work done, and this will continue in the future. On an international level, there's the Paris Accord, which limits warming to 2 degrees C during the century, 2 degrees Celsius. But the aspirational limit is 1.5. And what that means in a practical sense is that we need to cut current greenhouse gas emission levels in half by 2030 and reduce them to net zero by 2050. So that's the bottom line. That's what we have to do. Another thing that can be done is we can write our senators, representatives, and for those of us in the US, we can write the president. It's very, very important that we do this because really the citizens of the country have more power than they realize. I remember Ria, my wife, she was once on this committee, and I said, "Oh, you guys should do this." And she told me, she said, you need to send an email and ask the committee to do it, because you're saying it means a lot more than me on the committee saying it. And so if one of the people in the government says we should do something, it doesn't mean that, oh, thank you, Leah brought a glass of water. Thank you. It doesn't mean as much as when they can show that the population is backing their proposal. Okay. So I did want to mention this concept of adaptation and mitigation. These are very important. Adaptation means that we have the warming, let's say, and how do we adapt to it? Mitigation, on the other hand, means that how do we stop it? And so an example of adaptation is, I'm going to go to the store and I'm going to buy an air conditioner. Okay. And so adaptation may work for me because I have the money to do that, but it may not work for somebody who is poor, who doesn't have that capability. So often, if there are adaptation measures, the community or the government needs to make sure that the adaptation measures are equitable. Mitigation, on the other hand, for example, up here, limiting the temperature to 1.5 degrees C, that is a mitigation strategy. And so uh, we in Puerto Rico, where I am, for example, we can't do too much to mitigate global warming, but we can mitigate our contribution to global warming, and we do have plans to do that. California, on the other hand, is a huge economy, and it does uh, influence global air quality, and um, so mitigation is a possibility for the larger states. Another adaptation would be, for example, breeding crops that are heat tolerable or tolerant, or drought tolerant, something like that. So this will require applying these measures will require participation by all peoples and nations. Required changes will be cultural, political, social, religious, scientific, legal, educational. This problem of climate change is so universal in its reach. It literally covers every aspect of our lives. What do I mean by religious? I was thinking about this woman I know in climate science. She's very famous. Her name is Catherine Hayhoe. She's from Texas. And she is an evangelical Christian, but she's a leading figure in the field of climate modeling. So she gives presentations on how to talk to people that are resistant to the idea that climate change is real. So that touches on, it's definitely a religious conviction for some people. Um, on the other hand, we heard these beautiful writings today that clearly show that we are a part of our nature, the nature of the universe, and that we need to, you know, um, come in harmony and balance with nature. Um, so some other hopeful signs, there are a number of new energy sources being developed. One in particular that I really found interesting, it's called anti-solar energy. And the way it works basically is that during the day, the sun comes in and it stimulates um, the photovoltaic cell, and it converts that radiant energy to electricity. Well, it turns out that at night, and I referred to this before, at night, the land, or in this case, the surface of the solar panel, loses heat to space. So even though it's a small amount of energy, it's an energy transfer, and they can develop a type of photovoltaic cell that can convert that energy transfer to electricity. And so in the future, we may be generating energy at nighttime from our solar panels. So we need to develop more resiliency, each of us, in order to adapt to the situation. And so here is a couple pictures from my house. We have a 1 kilowatt solar system, It's a tiny system. It's just a backup system, but it works really well when the power goes out. When Hurricane Maria came, we lost energy for, I think it was about 3 months in our neighborhood. But at around month 2, we installed this system, and it transformed our lives. It was so great. We could run our refrigerator. We could do our clothes washing during the day. All of the appliances, not all of the appliances, but our computers and TV and stuff like that would work. Excuse me. Now over on the right shows our tank. It's a 600-gallon tank, and we collect rainwater. And this rainwater goes through a filter, it then goes through a pump, and it goes up into our plumbing system. And we just used it like 2 days ago because the water went off. Um, and so you do have to kind of we chlorinate the water in the tank, and you have to be aware of it, but aware of how to manage the system. But it's not that hard. Let me mention one thing about the solar system for those of you who are contemplating getting one. I will say that this type of a little system, or it could be a bigger system, but it's one that basically is standalone. It's not tied to the grid. It's not tied to the electric authority. Um, it does require some maintenance. So if you don't like checking the batteries to make sure that they have water, then you can get maintenance-free batteries. Or another way to do it is you can connect to the grid. It's called grid tied, and you're generating the electricity to sell to the grid, and then they give you a credit, but you're actually getting most of your electricity from the grid itself. A friend of mine just got one with 12 panels. He got a Tesla. I forget. It's called a Tesla wall, and he's paying $100 a month for 25 years. But he's totally happy with that because it's cheaper than what he was paying before. He has electricity when the electric authority goes down, and they maintain it, so he doesn't have to deal with any problems. So that's another thing to consider. Also, in terms of building resiliency, this food over here is from our garden, and Ria is the farmer in our family, and she's always harvesting food, and it really is a blessing. And so that's another thing that you can do, is start a garden. Um, Another aspect of resiliency is the community and working on community projects. And this is our Baha'i community here, some of our Baha'i community. And over here is a project we did after Hurricane Maria. We built a bridge for one of our friends whose bridge basically collapsed during Hurricane Maria. So what should be our attitude? I think that I think I'll skip this because we had the devotional, and it did such a fantastic job of explaining, what our attitude should be. But to put it in practical terms, we need to understand our connection with nature and with each other, and we need to develop a unified vision for our future. Um, And some of these writings Rick read. Um, so what is the Baha'i plan then? Um, the Baha'i plan is to raise a global network of people to work in support of an ever-advancing civilization and to address the core issues of our time. So our basic activities include children's classes, pre-youth groups, study circles, and devotional meetings like the one we had today. And the goal of these activities is to encourage spiritual growth, or that is to say, moral and ethical growth, and while providing the skills to serve our communities. So these basic activities, they build capacity for service. And currently in the world, our global network, if you will, has 1,500 social and economic development programs, 70,000 grassroots social action initiatives, 300,000 basic activities, 2 million participants, and 329 national and regional training institutes. So it is quite organized. And if any of you in the audience, those of you who are present today, would like to learn more about this, we have study circles. So one of the Baha'is can explain how to learn more about that. So the Universal House of Justice, which is the main governing body of the Baha'i faith, wrote, engagement with the revelation of Baha'u'llah has, in notable instances, transcended individuals, families, and extended kinships. What is being witnessed is the movement of populations towards a common center. At times, age-old hostilities between opposing groups are being left behind, and certain social structures and dynamics are being transformed in the light of the divine teachings. So for the Baha'is, what we believe is the most important thing is unity, because in the future, the near future, we could have the outbreak of wars and social disruption, the like of which we haven't seen. And it's all about building community and unity. And some of these things it's talking about here, for example, social structures. Through the study circles, there have been communities, for example, in India, where women have gained their rightful place in the community, where there's now more equality in their families, that because the whole family is involved in this process of growth. And so they understand that their girl children need to be educated, and they can't be married off when they're, through arranged marriages when they're children, and that kind of thing. So this is just an example of some of the another thing is the racial harmony work in the United States. The Baha'is are very, very involved in that work. So I'll just close with this. Baha'u'llah said, the earth is one country and mankind its citizens. So that's all I have. And if there are any questions, I can take those if there's time.